Assalamualaikum warahmatullahi wabarakatuh. We are from Group the Asst.
We are going to present the mixture of two compartments in open system.
Stay tuned.
Enjoy! Binti Mohammad. So I will introduce to you the background of study for our project. Basically, multi-compartment model is a type of mathematical model used for describing the way of materials or energies are transmitted among the compartment of a system. Each compartment assumed to be a homogeneous entity within which entities being modeled are equivalent. There are one compartment of a system and two compartments of a system. However, for our project, we only focus on mixture in two compartments of a system. In real life, compartment models are broadly used in modeling process such as the movement of drug in human body. Modeling have been used in order to solve the equation of the mixture into compartment system. Laplace transform and second order ordinary differential equation were used to obtain the rate of salt flowing from tank 1 to tank 2. So, I will explain to you the objective study for our project. The first one is to solve the second order differential equation of the mixture into compartment of a system. Second is to apply Laplace transform while calculating the amount of salt in both compartments. And lastly is to study the dynamics of amount of salt transported between the two compartments. Okay, so we proceed with our scope of study. A compartment model provides a framework for the study of transport between different compartments of a system. In medicine, compartment model was used to study the dynamic flow of chemical in the human body, such as drugs. Compartments are represented. Okay, so from this figure, we can see that compartments are represented by the boxes, and the arrows are the inflow and outflow of the substance. Okay, in this project we focus on a mixture of two compartment system. A linear cascade diagram is a diagram of compartment in which input and output rates have been assigned from one or more different compartments. So this diagram is a brief way to summarize and represent the various rates of The method of compartment analysis translates the diagram into a system of linear differential equations. By that, we introduce on how to solve the differential equations for two compartments open system by using Laplace transform. Assalamualaikum. I'm Umaira. Will explain about the literature review and the models. Okay, for the literature review, a book titled Differential Equations and Their Applications, written by Asst, offers information on the study of application or situation regarding the compartment systems. Okay, this book explains about the mixture problem involving two compartment system. Okay, from that, typical mixing problem deals with the amounts of salts in a mixing tank. Okay, salts and water enter to the tank at a certain rate, and they are mixed with what is already in the tank, and the mixture will leave at a certain rate. Okay, this process is modeled by an ordinary differential equations. Okay, the first ordinary differential equations is the concentration of salts in liquid and stream. Okay, ds over dt equal to y over 60 minus 3s over 40. Okay, for this equation 2 is the concentration of salts in liquid azimuth. Okay, dy over dt equal to 3s over 40 minus y over 60 plus y over 30. For the initial condition, y0 equal to 0, y prime 0 equal to 3 over 40, and for the st equal to number of kilogram of salts in tank 1 at time t, yt equal to number of kilogram of salts in tank 2 at time t. So, from the equation N1 and 2 are the equations of dynamics of salts. In order to perform Laplace transform, both equations must be combined to produce second order ODE. So, the second order ODE is this squared s over dt squared plus ds over 8 dt plus s over 400 equal to 0.
Assalamualaikum. My name is Fairuz.
So I will explain to you how to solve the model purpose that have been introduced by my friend just now, Nurul. So the model purpose of our problem is d square x over dy square plus by 1 over 8 dx over dt plus 1 over 400 equal to 0 with the initial conditions x0 equal to 0 and x prime 0 equal to 3 over 40. So in order for us to solve this second ODE, we need to perform the Laplace transform. So we perform Laplace transform for this equation for both sides. By using the table of Laplace transform, we will get this result, which is x square xs minus by x0 minus by x prime 0 plus by 1 over 8 sxs minus by x0 plus by 1 over 400 x0 equal to 0. Next, from the initial condition, we are going to substitute this initial condition into this equation, and it will result s square xs minus by 3 over 40 plus by 1 over 8 sxs plus by 1 over 400 xs equal to 0. Next, we're going to factorize this by bringing this 3 over 40 to the right hand side and factorize the xs. It will result this. After that, we're going to bring the others, the left hand side here to the right hand side, and we will gain this result. So from here, we're going to perform the partial fraction. Next, we will perform the partial fraction for this equation. For this equation, we need to simplify the denominator and gain this result, which is 30 over 40s plus 1, 10s plus 1. We need to find the value for a and b, and we already gained the result, which is that a equal to 40 and b equals to negative 10. Substitute the value of a and b into the equation, and we gain this one. So next, we need to perform the inverse Laplace for both sides, the right hand side and the left hand side, and we gain this result. After that, we need to, by using the table of Laplace transform, we get the result, which is the general solution for our problem is exponent negative 30 over 40 minus by exponent negative t over 10 equal to xt. So that's how we solve our problem by using the Laplace transform. So next, we will proceed to the interpretation of results. So this is a graph that we get from the maple. A graph the amount of salt against the time t. So as the time t continuously, the amount of salts will be decreasing. That means the amount of salts exchanged between the two compartments is almost the same.
My name is Mashara. I will make the conclusion. Okay, to conclude, our goal for this project is to determine the amount of salt transported in the mixture after t time. To find this, we use Laplace transform in order to solve the second order ordinary differential equations. After we get the result, the ODE depicts correctly according to the flow of the salt from one container to another container. The rate of salt moving from container 1 to container 2 lower than the salt moving from container 2 to container 1. This will result the accumulation of salts in container 2 to be faster. So for recommendation, we suggest that the water and the salt should be diluted evenly, because if the salt and the water not dilute evenly, this will cause the salt to be sediment. The sedimentation of salts will make the calculation to be imprecise. Okay, that's all from us. Thank you.